Okay, section 1.4, starting to look at angles here. And an angle consists of two different rays that have the same initial point. So remember, the initial point is that starting point of a ray. And so an angle has two rays that are sharing that same initial point. So here's our angle. We have one ray here, another ray here. So point A is the initial point for both rays. So that makes it the vertex. The initial point is the vertex of the angle. And then each one of these rays, ray AC and ray AB, would both be considered to be sides of the angle. And whenever we're writing and trying to use shorthand for angle, we can use a symbol that looks just like an angle to be read as angle in a problem. So this angle here with ray AC and ray AB as the sides could be named three different ways. We could name it as angle CAB, angle BAC, or we could name it with just one letter using the vertex of A and call that angle A. One thing we have to make sure of when we name an angle is that the vertex is always the middle letter if we're doing three letters. Like we see here, the order doesn't matter as long as A is in the middle, which tells us that that is the vertex of the angle. So here we have this picture here, and we want to name the angles in that figure. And there are actually several different angles in that picture. So we have angle CDE, or that could be angle EDC, right? So angle CDE or EDC is this angle right here. And then we've got an angle right beside it, angle EDF. Or we can actually go in reverse and say angle FDE. And so we have those two angles side by side, and then we actually have one big angle that makes up those two angles. So angle CDF. Or we can call that angle FDC. Now, one thing to mention here, notice we used all three letter namings here. We didn't use a single letter. In order to use the single letter for the name, there has to be only one angle that has that vertex. And in this picture, every angle in the picture or in the figure has point D as the vertex. So all three angles we listed here all use D. So if we just said angle D, we wouldn't know which one of the three angles we were talking about. All right, so measure of an angle is denoted as a lowercase m in front of the angle symbol A. So lowercase m is read as the measure of. So measure of angle A is what we would see here. And if we have congruent angles, those are going to be angles that have the same measure. So if the measure of angle BAC is equal to the measure of angle DEF, then we can say that angle BAC is congruent to angle DEF. Remember, the equal sign with the little squiggly line is the congruent symbol, which just says we're comparing two things that are exactly the same. So in this case, if the measures are the same, if one had a measure of 60 degrees, the other one would also have a measure of 60 degrees. All right, so postulate 3, known as the protractor postulate, kind of similar to the ruler postulate we learned earlier. So it says consider point A on one side of line OB. The rays of the form OA can be matched 1 to 1 with the real numbers from 0 to 180. the measure of angle AOB is equal to the absolute value of the difference between the real numbers for OA and OB. So, since it's a protractor postulate, that means we can use a protractor to help describe it. So what it's saying is, if I have an angle, you got ray OB and you got ray OA, and using a protractor, each one of those arrows is going to hit a certain number on the protractor. Of course, if you're trying to measure an angle or come up with the measure of the angle, the easiest thing to do is to set the arrow at 0 and then measure the exact distance around. But just like when we did the ruler, we can put the ends or the sides of the angle anywhere on the protractor and then just calculate by finding the absolute value of the difference. So if I just leave it right there and look at the values here, then it depends on which side I'm looking at. Right? If I use the 0 on this side, it comes around to 180 on the outside. The inside starts at 0 on this side and works its way back to 180. So I'm just going to use the outside ones because the measurements are a little easier to read. We don't have to interpret from the inside out. So the number value here, well, that's 150. Next big spot is 155, 56, 57. And then over here, we're at 10, 11, 12, 13, 14. It's kind of between 14 and 15, looks a little closer to 15. So I'm going to call that 15. So the measure of that angle can be found by saying, first off, let's name it. The measure of angle AOB is going to be equal to the absolute value of the difference of 157 degrees minus 15 degrees. Which will tell me the measure of angle AOB is equal to 157 minus 15, should be 142, or just 142 degrees. Alright, so then on from there, the point is in the interior of an angle if it is between the points that lie on each side of the angle. So if we have an angle here, this is a side and this is a side. So in between the two sides, any point inside that area is known as the interior of the angle. And if the point is not in the interior or on the angle, then it's considered the exterior, like point E here. So postulate 4, the angle addition postulate, very similar to the segment addition postulate, just saying that if I have a couple of angles that are attached to each other side by side, then if I add the measure of those two angles together, that will give me the measure of the big angle. So in this picture, I can say the measure of angle RST, or measure of angle RSP, this angle here, plus the measure of angle PST, so this bottom angle here. So if I measure those two and add them together, then that's going to equal the measure of angle RST, the outside angle. So the two small ones added together equals the whole, or the big angle. So this next problem says the backyard of a house is illuminated by a light fixture that has two bulbs. Each bulb illuminates an angle of 120 degrees. If the angle illuminated only by the right bulb is 35 degrees, what is the angle illuminated by both bulbs? So, we got two light bulbs side by side, and each bulb is illuminating an angle of 120 degrees. So that blue angle is 120 degrees, and the black angle is also 120 degrees. So each angle lights 120 degrees. It says the portion lit only by the right bulb, which would be this section right here, is going to be 35 degrees. So it wants to know what is the part that is illuminated by both, which would be this section down here in between, which is going to be our X. So we know that the blue angle here is all of the right bulb. This part is just the right bulb that lights it up, and then the rest is the overlap. And so the 35 degrees of just the right bulb plus the X portion there in the middle that's overlapped has to equal 120 degrees. And if I subtract the 35 degrees from both sides, then X, which represents that part illuminated by both bulbs, would be 85 degrees. Alright, so then from there, we've got several classifications of angles. Most of these you probably already know. Right? They're classified as acute, right, obtuse, and straight based on the measurement of the angle. And angles have measures greater than 0 degrees and less than or equal to 180 degrees. So any angle measurement is going to be somewhere between 0 and 180. So if it's an acute angle, the measure of that angle is going to be between 0 and 90 degrees. So greater than 0 degrees, but less than 90 degrees. A right angle, the measure of angle A is going to be equal to exactly 90 degrees. If it's an obtuse angle, then the measure of angle A is going to be greater than 90 degrees, but less than 180 degrees. And a straight angle is going to have a measure equal to 180 degrees. Notice a straight angle also looks kind of like a straight line or even a set of opposite rays, which is good information to keep in your mind for later on when we start looking at some other things. Alright, so here it wants us to plot points A, B, C, D, and E, then measure and classify the following angles as acute, right, obtuse, or straight. So I've already plotted these points for us, A, B, C, D, and E. And we want the measure of angle DBE. So angle DBE. Go ahead and make that angle. Notice B is the center point, so that would be our vertex. So we're going from B is the initial point through D, and from B through E. And then we're going to measure that with our compass. And for time's sake, I'm not going to put it at a random setting. I'm just going to set it at 0 on this side. So 0, 10, 20, 30, 40. We're between 40 and 50, so then we come out here to the small increments. I got 55 or 45 and 46. So this is going to be 46 degrees, which is less than 90 degrees. That's going to mean that angle DBE is an acute angle. And then going on from there, the next angle is angle EBC. So EBC, so we're going to go from B through point C. Grab our protractor, put it over here, get that lined up. Line it up. There, we're at going right through 90 degrees there. So angle EBC is 90 degrees, which would make that a right angle. Next one is angle ABC. So we need to go from B through A. Which this one should be pretty easy to recognize. So when we look at it, it looks like a straight line. We can go ahead and put our compass on it. Lined up. Starts at 0 here and ends at 180 there. So 180 degrees, which makes that a straight angle. And then the last one on the list, angle ABD. So starting at 0 here and ending at, there's 130, 132, 33, 34. So 134. And that would make that an obtuse angle. And so that finishes that example. And it says adjacent angles are angles that share a common vertex inside but have no common interior points. So when we talk about adjacent angles, those are angles that are side by side. They share a common vertex, right? They all have the same vertex there. So if we have angle A, BD, C. So the adjacent angles would be the two angles that are side by side. They share a vertex and one common side. So in this picture, that would be angle ABC, which is side by side right next to angle CBD. Okay? And so those are adjacent angles, meaning side by side. And that finishes the note.